Hey, Vsauce, Michael here. Or am I there? Either way, one of us was doing the dishes the other day, and we realized when we turn the water really low down, that there was a stream coming out of the faucet, but as it reached the bottom of the sink, it was in droplets. So today, we're going to be understanding why water turns into drops. Here at my bathroom faucet, we can see that as the water leaves the tap, it begins as a stream that gets slightly narrower as it begins to fall. As it falls further, however, we can see that the water stream turns into individual drops, as is shown in the shadows that have been cast on the bottom of the sink. That leads us to question, what happens from the stream as it falls further that causes it to turn into droplets? To understand why water turns into droplets as it falls further, we first need to remember that the stream narrows due to the acceleration of gravity on the water. This means that as the stream has a smaller diameter as the water accelerates, that more water is exposed to air. This may seem like it doesn't matter, but as we look at the water stream on a molecular level, we can imagine this picture as the water molecules in the center of the stream, with them being attracted to every molecule around it with the same amount of attraction. Imagine in this picture, however, that we're looking at the molecules on the outside of the stream. Since they are attracted to less molecules because half of its attraction is gone since it is just air, there's more attraction to the water on the inside of the stream, therefore it's drawn inwards. The reasons why these water molecules are attracted to each other is in part because of the gravitational pull between even the smallest of objects, along with the fact that water molecules have both a positively and negatively charged side. These oppositely charged sides attract one another throughout the entire stream or eventually droplet. This can be shown as the water is passing by this magnet that I'm holding, with the fact that even though the magnet and the water do not touch, water droplets still form on the magnet from where they are attracted out of the stream of water. Because the water accelerates over time, the stream becomes thinner and thinner, meaning that more water molecules are subject to touching the air and being more attracted to the water molecules on the inside of the stream. Over time, this effect draws them closer together, eventually forming drops. In order to be the first to name this phenomena, I will deem it dropilating. In fact, my first example of dropilating is shown above in an inkjet printer. As the paper is moved through the printer, the ink cartridge moves over it and in precise measurements dropilates ink onto the paper, and in order for this to be correct, the machine has to have a knowledge of the gravitational attraction between the ink particles due to their density, as well as how the particles are attracted to each other based on their charge. Without this knowledge of how ink can be dropilated in our daily life, we would be stuck using older methods of printing. And as always, thanks for watching.